you want to calculate stress Z, so this one is equal to moment in the y direction divided by Iyy multiplied by x. Right? So you realize that for this case, right, element A for this case is equal to 0. Right? Why is it equal to 0? Because element A is at the neutral axis. Okay. You did not know that until you analyze, right? So this is important. I better leave some space. The thing about doing structure analysis in this way is you really have to get very, very organized. If you're not organized, you're done. Okay. And then the next one is your shear force. Okay. So shear force in the x direction. So this will be equal to twice. Okay. So we have 2. So twice. So I'm going to take positive towards the left. Okay. So I mentioned about forces in the x direction. Okay. So it's 8 times 10 to the power 3 times 2. So this is 16 times 10 to the power 3 Newton. Right. So for this case, we know that there's going to be shear stress. Okay. So the shear, don't worry about shear in which direction yet. Okay. So the shear is equal to Vx over Iyy, right? Qy divided by T, right? And then if you want now one thing that will really help you is this. Okay, one thing will really help you. So once you draw this, right? So now this is my shear stress, right? So this is now our x direction, right? The shear stress will be at the maximum on the neutral axis, right? If the element is over here where I'm drawing now, right? So this is element alpha. The shear stress will be equal to what? 0. Yes or no? But if the fact that it's not at alpha position, is at element A the position, you're going to have a maximum shearing stress. So we will write down here, you have element A will observe tau max. Okay. So anything else to analyze? You just see down here. Anything else to analyze? The answer is no. Anyone has question? I can hear someone unmuting.
Yep. I have a quick question, Eugene.
Yes.
We said element A is that on neutral axis, so that's why our x is 0 for our normal stress, right?
Yes.
Okay.
Right? Because on normal stress, remember the diagram we draw. Remember when we started our lecture? This thread is so important. Remember, on the normal stress, on the neutral axis, the stresses are 0, but it's maximum away from the what? Neutral axis.
Okay.
On the shear force or shear stress, it's just gone up. A shear force induced, shear stresses inducing by shear force is the opposite, right? At the neutral axis is going to be at the what? Maximum. Right?
Okay.
At the torque, right? The maximum is if we have a shear force, a shear stress induced by torque, the maximum is away from the what? Neutral axis. So you have to know where is applying what. This is so critical. Okay, that's why there's very limited engineers that are capable to analyze structure like this. Okay, because it's a lot of integration, and a lot of times we don't like integration. I never like integration until I start teaching this course. Okay, right. So from here, anything else we can analyze? The answer is no. Okay, so we have to move on. Okay, so let's do the other stresses now. Okay, so I'm going to draw a different view now. Okay, I'm going to draw. We're going to look at a different view now.
Eugene, so in the last step, you said element alpha shear is 0?
Yeah. Why? Because it's furthest away from the neutral axis. Hello? Right?
Yeah.
Okay. Right, that's why I draw the I drew the distribution. Okay, now this one, a lot of time, engineers and students make a lot of mistake. I'll tell you what is it. Okay, withdrawal transformation. Z. Okay, so now we are going to view on the YZ. Okay, so this is Y, and this is Z, and then I'm going to use right hand rule, rotation in the X. Okay, then I'm going to draw the beam. Right, and now I can see two lines. Right. Okay. Then from here, right, I'm going to draw the position of my neutral axis. This neutral axis is so important. Without it, yeah, it's so difficult. Okay, so this is our neutral axis. Okay, and then built in. Then the next thing is our element A. Okay, that's our element A. Then we start drawing our forces. So we have 8 kilonewton going in, right? We have 100 kilonewton over here.
Hey Eugene, sorry. I'm trying to picture again the shear for element A. Why is it maximum at element A? Can you go back at it? Sorry to.
Because element A is at the crosses the position of the neutral axis.
Right, but isn't shear at the neutral axis equal to 0?
I'm leaving you to think about this.
Okay.
All right. Neutral axis, shear is maximum.
Oh, okay.
Bending moment, neutral. Okay. When you see this graph, okay, this chapter, the most important thing is these graphs, these formulas, and example number 1. Okay. You have to grasp this concept, what force induce what stress, what moment, and how they distribute.
Yeah,
okay.
Yeah. Sorry,
okay.
I got confused.
I know. No. This is you did not get confused. Okay. It takes time to remember. There's no confusion down here. You're not confused. It just takes time. Okay.
Okay.
There's no
Thanks.
confusion. I know you know your work. Okay. It's no confusion.
Thanks. I'm sorry.
No, don't be. So this is equal to 25 kilonewton. Okay. This is where things get very, very. Let's do the easy part first. Okay. So sorry. The shear stress. Okay. I want you to look at the shear stress times 10 to the power 3. The shear stress is in which direction? The shear stress is going in. So I want you to start drawing the arrow also in this direction. Okay. Right. So the next one is, this is where things get really, really tricky. Okay. I'll explain to some it's obvious, to others might be not, but it's okay. Okay. So we know that there's a do the simple one. So Vy, right? The shear force in Y. Yes, I mentioned about forces in Y. Hey, Vy is equal to 25 times 10 to the power 3 and is acting towards the what? Towards the right. Now, I will caution you to see. Now, this is a 2D view. Okay, so this is just a general trend. I'm going to repeat that this is just a general trend. Okay. In fact, I will not say tau max. I'm going to say element A is going to observe shear stress. Let's put it that way. Okay. This is just a general trend. Okay. Now, when you look at Vy, this trend, I know that it is not away from, is away from the neutral axis. The shear should be equal to 0, but it's not. Okay. Why I say that this is general trend? This is a general trend. Okay, general trend. Because we have to analyze the cross-sectional area also. Okay. Later, I will elaborate. I'll elaborate this very, very shortly. Okay, not later. We will elaborate this very, very shortly. Okay. So from here, next is the moment. Okay. So the moment, we're going to calculate moment about the x-axis. Okay, moment of the x-axis. So from here, right? So I'm going to call clockwise to be positive. Summation of moment in the x direction at point A is equal to, now the 25 kilonewton is going to be positive. The perpendicular distance is what? It is the perpendicular distance is 0.5, right? Now the 100 kilonewton, what is the perpendicular distance? Anyone? What is the perpendicular distance of the 100 kilonewton?
So 150 plus the thickness of the beam.
So I'll write down the perpendicular distance. Okay, the perpendicular distance. So if you look on the table, right? So we are looking at D, right? D is 205, right? So the perpendicular distance is 205 times 10 to the power minus 3 divided by 2. Okay, let me write this out. Okay, so the distance from here to here, the distance from here to here is 205. Hey, 205. Right? The distance from here to here is 205 divided by 2. Right? So some of you will say, Eugene, something is very wrong, right? Why, when this case, we will take the what? We will take the 0.5 meters, right? And then the 100, we don't take the 205, right? Yes or no? Right? You say, hey, I'm confused now. Or is it just me? Right? The 25 kilonewton, I take the 0.5. The 10 kilonewton, I don't take the 205, but I take the 205 divided by 2. Okay? So let me calculate this value first, okay? Then I'll tell you why. So this will be equal to 25 power 3 times by 0.5 plus by 100 power 3 times by 0.205 divided by 2 is 22750 Newton meter, right? And then it's going in this direction. So when it's going to that direction, right? So we know that this is compression. This is tensile. So at this mode, you know that element A will see tensile. Okay, now Why the 25 you multiply by 0.5? Whereas the 100 you multiply by 205 divided by 2. This is because the stress is equal to